Page 111, lucky number 13. Complete each row with an equivalent expression in standard or factored form. So the first one is standard. If I was to break that up, what would I get?
X times X.
X times X is factored form. Then it gives me the factored. So if I was to distribute that, X times X is, and X times 9 is, all right, somebody other than Georgia. Third one. What can I take out of x squared minus 18x? What do they both have in common? They have an x. So I'm going to take it out. X times what would give me x squared? X times what would give me negative 18x? Very good. Easy to check and see if you got them right. If you distribute that x, you better get what you started with. Why don't you try the last three? So, let's check it. So the first one, I think this one is kind of an easier one compared to the other two just because of the negatives. But if you distribute that x, 6 times x, or x times negative x. Now that is not written in right form, so I would prefer that. But in this case, they would both work. Next one, you have some options. Some people will take the negative out. Some people will just take the x out. So it's kind of up to you. I'm going to take just the x out. So my first term is still going to be negative, and my last term is just going to be 10.
Could you do negative X?
If you take a negative x out, then you're going to get x, and you're going to get a negative 10. But yes, that would be fine as well. Last one there, I'm going to take negative x times x and negative x times 2.75. If you need to draw the arrows, feel free. If you want to draw the diagrams, that's fine as well. Yes?
For that one before, I'm gonna do x parentheses 10 minus x.
Yep. That would be fine too. What do the quadratic expressions in each column have in common? Besides the fact that everything in the left column is in standard form, everything in the right is factored. So what does everything in the left have in common?
X squared.
Always have an x squared. What's nice about that is in standard form, if you see that, you know it's a parabola immediately. This one's a little tougher to see, obviously no x squared, but a lot of x's, if you will. More x's than the right. Parentheses is another good thing to point out. Left column has no parentheses. Right side does. All right, so now wants to know about the linear term. So yesterday we did that one example and I was like, oh, we're not going to cover that yet. Well, today's the day. So the linear term just means it has just an x on it. So yesterday we just added a +5, +7, just a whole number. That moved its height. So now if you graph these, again, bring out Desmos and let's make an observation of what happens. So go ahead and graph those four on Desmos and let's take a peek.
Dang, that's a big route.
Super steep. Can't even see it.
All right. So the red one is the parent one, right? The basic one. So concentrate on the vertex, the point where it starts. The second one, the x squared plus 4x, what did that do to the vertex? What did it do to this point? Where did it go?
It moved it over left,
Left and
down.
down. I'll make a little note of that. Moved it left and down. How about the green one? That would be the x squared plus 20x.
Left and down.
Left and down. Left further and down further. And then how about the minus 50x?
Right.
Right and down. Okay, so it appears it moved them all down. Negative moved it right. And then it seemed like the bigger the number, the more it moved the vertex. Would you agree with that? The bigger it is, the more it moved it. So let's change it. Exact same problems. And just change the sign in front to negative. Now from yesterday, what does that negative do?
Flips it.
Flips it. It's going to open the other way now. Let's see if anything else changes.
What did you?
Negative in front of the x squared. How does the first one change?
Upside down.
Does it still shift it down and left?
No.
Now it is
Down and right.
up and right. So I'm guessing the 20x is also up and right. And then the last one is up and left. And then all opening down. Again, good thing to get in your notes so you have an idea of those changes. Every time you see that, that's going to have the same type of change. Again, a linear term just means just an x.
Can I get Parker or Ultimate to the junior high office, please?
Okay, so x-intercepts. So you have two options here. You might be able to see it after you do a couple. I'm going to factor out an x like we did in example 1 until I get used to being able to find the x-intercepts a little easier. So I just factored out an x. I can see my x-intercepts are 0 and -6. And then my coordinate of the vertex would be halfway between 0 and -6. It would be -3. If I wanted the other part of that, I'd plug in -3 to get the y-coordinate of the vertex, but it's not asking me that. Okay, next question. Again, I'm going to factor out an x. I see my x-intercepts are 0 and 10. Halfway between 0 and 10 is 5. See a pattern yet? Seems to always be 0. And then it looks like it's the opposite of this number, opposite of the linear term. Let's see if that holds true again. Well, this is a +6, my x-intercept was a -6. This is a -10, my x-intercept is a +10. Maybe that'll change with a negative out front. I'll just take that out. Just took a regular x out. X-intercept, what makes this 0 is just 0. The opposite of what plus 50 is 0? The opposite of what plus 50 is 0? Should just be 50, because it's a negative in front. So the pattern doesn't hold true that we mentioned because of the negative out front.
How does that change the
Because the negative affects either the outside or the inside. If you took a negative x out, it would look like this. And it would still be 50. So the negative just messes everything up. So it looks like if you have a positive x squared, it's the opposite of this. If you have a negative x squared, it's just going to be whatever is in front of the x. So the next one is going to be 0. And what's in front of the x? -36. So there is your rule. Halfway between 0 and -36? -18. So here I have a positive x squared. It says some quadratic expressions have no linear terms. Find the x-intercepts. Okay, again, you could graph it. It's saying, let's see if we can get it without graphing. So Georgia, you asked if we're going to be doing any factoring. Here's a baby step for it. So you know you don't have any middle term. You don't have a linear term. You don't have an x. That means both of these things are going to be the same, just with opposite signs. Because that's the only way that they would cancel out. Plus 3x minus 3x. Plus 4x minus 4x. So give me two numbers that are the same. That give me 25. Multiplying. 5 and 5. So now if you were to FOIL that, just to prove it to you, these cancel out. And you're left with x squared minus 25.
They have to be the same numbers?
They will have to be the same number. Let's try another -1. Let's do x squared minus 49.
Are they always gonna have like an equal thing?
I have no idea what you mean by equal thing.
Well, like, are they always gonna have like 7 times 7?
Yes.
times 8?
Okay, again, you're gonna have one of each sign. That's the only way the middle term will cancel.
7.
And it's going to be 7. Okay, it is asking me for the x-intercept, so of course it would be 5, -5, 7, -7. Order doesn't matter. Now here's a trick. If it's a plus, some people think, well, it's just x plus 4 and x plus 4. Well, if you do that, you get a middle term. That's not the same. Well, then they'll say, well, how about x minus 4? Well, then you get x squared minus 8x plus 16. That's not the same. Well, how about one of each, Mr. Milbrandt, like we did before? Well, then you're going to get x squared minus 16. That's not the same.
So you can change the number.
So if you ever have a plus like this, your answer is no x-intercepts. So if you were to graph that, it doesn't cross the x-axis. That's why you can't find it. It doesn't exist. Your graph is up 16 and goes that way. It never crosses this line. There are no x-intercepts. So if you have x squared plus 49, no x-intercepts.
So you can't ever force that one.
Nope, not with a plus. The ones with a minus, it's always something squared minus something squared. Actually has a special name. It's called the difference of squares. Difference just means subtracting. Squaring just means, you can see I'm squaring both of them. So any of them that you're minusing, it's in its own special category. So the minuses you can do it, pluses you can't. All right, the last questions. We're going to use Desmos to help us graph these. Okay, to help us come up with the exact graph. Anybody think they have A? What is the graph of A? Yes?
It's just x squared.
Y equals x squared. Okay, it does say make sure your graph goes through these points. B. What points does it go through? What are my x-intercepts? So that means my factored form would be x plus 3, x minus 3. Make that into standard. And it's just x squared minus 9. Does not say if it wants factored or standard, so either one is fine. And maybe you said, all that is just slid down 9, and maybe you got it that way. Just down 9, that's why all it is a minus 9. Question C. What are my y-intercepts? Sorry, x-intercepts.
-2.
So x plus 2 and x minus 3. That would be the factored form. If you want standard, you'd FOIL it. X squared minus 3x plus 2x minus 6, combine like terms. And again, we knew there was going to be a linear term. We knew there was going to be something with an x because it shifted right and down. So we knew it was going to be something there. Same thing with d. There's going to be a linear term. There's going to be something with an x because it shifted left and down. What are my y or my x-intercepts? 0 and negative 6. So x plus 6, x minus 0, or I can just put x. Distribute. X squared plus 6x. E. What do we know is true about that one?
It's a negative.
It's a negative, so it's going to be a negative x squared. It does not get shifted left or right, so there is no x term, but it is shifted up 4. You also could have wrote down the x and y intercept, and then just made note that it's going to be negative. That would work as well. F. How many x-intercepts do you have?
1,
What is it?
2.
All right, so anytime you have that, it's the same factor twice. If you didn't do it right twice, you would never get a quadratic, but we can clearly see it's a U-shaped. Okay, help me multiply that out. FOIL it.
X squared.
Plus 4. Or, no.
X times negative 2, negative 2 times x, and then plus 4 at the end, yes. Again, you knew there was going to be an x term because it shifted. Question G. Is there going to be an x term?
Yeah.
Yes. And it's going to be negative. All right. So my factors are minus 1 and 3. Make a little note that it is going to be negative as well. So help me FOIL. X times x, x squared. X times negative 3. 1 times x. Negative 3 times 1. So x squared minus 2x minus 3. Whole thing is negative, so you technically can just flip the sign on everything, so you don't have any parentheses if you want. That would be the most exact you can get. Question H. Why don't you try H? Use your x-intercepts and FOIL it. Draw a diagram if you need. Got it, Caleb?
Sure.
Again, you can just trial and error all of these on Desmos as well. You're just looking for a way to go through those 3 points.
How do they?
Let's actually try that for I. Start with this equation. See if you can get it to go through those points. So write down y equals x squared. Change it on Desmos to try to get it to go through those points. Will there be an x term? Is this one shifted left or right? Nope.
It's just skinnier.
Oh, skinnier. So from yesterday, how do I get it skinnier?
Put a coefficient.
Okay, so what do you want to try?
I don't know. Is there no way to like figure this out?
What do you want to try?
2.
Try 2, see if it goes through those points.
Yeah.
Yes? Jay. What do we know about that one?
Wider, so it's gonna be
And
less
it's gonna be a
than one.
negative.
It's going to be a negative and it's wider.
Oh,
Yeah,
when is it less than one then?
it is less than 1. That's what makes it wider. So try a number in there.
What if it was less than one, makes it narrow?
What's that?
What if it was less than one, and narrow?
Was it an error number?
Narrow.
No. Bigger the number, the narrower it is. You want it to go through 4, -4, and -4, -4.
Negative 0.25.
-0.25, or -1/4. Again, the book wants you to just trial and error all these. Mostly so you get used to just, hey, what does this number do? What does a negative do? What does this number change? Okay, so when in doubt, trial and error. And you'll figure out what those numbers do to help you along the way. Okay, take a look at page 117. Matching again to start, match a graph with the equation. 2 is completing the table. We did one just like that on your homework. Please reference that. 4 is select all. 5 is what we just got done doing. Keep in mind, if it's shifted left or right, you will have an x term. 1 will have a x term and 3 will have an x term. 6 is matching again. I think the rest you can handle. So 117 to 119.